Oh, no, wait. There is something else going on here.
Hi,
Hello.
friends. Hi,
It's us
Victor.
again.
It's us again.
Better Wi-Fi this time, huh?
Could it be worse? Only one way to go. Let's do this again. It was so fun the first time. Let's do it a second time. What?
Yeah, I mean, it was so fun to us, maybe not to anybody else, right? I got a video from somebody recorded from the audience. My mic was not even working. Not counting even the stream was completely messed up.
My favorite part of the disaster that was our attempt at a live stream was the fact that we forgot to press the start stream button until 14 minutes in.
That means that we saved people 14 minutes from misery. That was 14 minutes less of misery. So it was a
actually, they never saw it. So it was actually perfect streaming. We couldn't have said anything better. Anyone who was present now has perfect clarity about all Kubernetes related security. Too bad we forgot to hit record.
Security reasons, Whitney. For security reasons.
We've come such a far way. We've gone through 10 different system design choices as part of this journey. What's a takeaway for you? What have you learned? Just one
Security
thing.
is still boring. I learned nothing.
Great.
But I will pretend that I learned a lot and explain people things.
Oh, come on. It was great. It was lovely. Literally
That was
everything
such a
I know now.
condescending, come on. Okay.
That's true. I'm sorry. You're not wrong. Everything I went into this knowing nothing about security. So everything we talk about today is stuff I've learned in the last 3 months. So I've been working hard over here with my Lightboard. I have folks come on and talk to me about the projects on my other show called Enlightening before I review them here. So I'm it's not solely from YouChoose 5-minute YouChoose presentations. But let's shall we dig right in?
Yeah, let's do it.
Let's do it. We have 10 of these to get through. So the first episode we talked about admission controller policies, which I like to call cluster level policies, because those of us who are brand new have no idea what an admission controller even is. So what is an admission controller? Why do we need cluster level policies?
It's a mechanism in Kubernetes itself to allow or deny propagation of a resource, ultimately to etcd, right? So it's a mechanism, built-in mechanism that that is fired whenever we submit something, and that's opportunity to say nope.
Yes or no, or to change it. And it's not necessarily when you make a resource either. You could be changing a resource and that could come up
any
against
request
a policy.
to change the state. So most of the time you don't do kubectl create, you actually do apply, right? Which is saying, hey, I have this manifest. I don't know whether you should create it or update it, do whatever needs to be done. Whenever something is sent to Kube API.
Yeah. So basically, you're adding, with admission controller policy, you're adding organization-specific rules to what should happen when a resource gets created or updated or deleted, or the CRUD actions. Yeah. When some action is applied to some resource, there's a rule. There could be a rule.
What will happen with that resource that would be mutating? Admission is more like yes or no.
So
go, no
yes.
go.
But there's there's mutating admission controller or there's validating admission controller, but they're both admission controllers.
Exactly.
Yeah. So when you make an organization-specific rule, that adds some extra configuration to Kube API in the form of an admission controller webhook. And basically that configuration is going to look out for any possible action plus resource that comes through. And if anything falls under the jurisdiction of that rule, it's going to send the request to the admission controller. And the admission controller is a piece of software that's running in the cluster that's either going to do validation or mutation. Why would you want to do mutation? What's an example of that?
I think that more often than not, you don't want to do mutation. I mean, I know that many people do. I don't think that people should be doing mutations. I think that mutations are the good use cases for mutations is through third parties, right? Oh, I just applied this thingy that will create pods, mutate it so that sidecar containers for service mesh are added, right?
Okay.
I mean, you can choose your own mutations. I think that that's hiding certain things. So I'm not very fond of that, doing it ourselves, but third party, definitely.
So in your opinion, it would be, especially for organization-specific stuff, you want it to be fully declarative, stored in Git.
Yeah.
And you should.
I would rather. So let's say that you send a manifest, let's say a deployment, and you can have two options. One is, hey, if resources are not defined, set them to this, right? Set them to this. Or validating would be, you cannot do it without defining them, right? I prefer the latter simply because it teaches me as the person who submitted, okay, so actually I should have those things, right? Mutating in this example would be, hey, I'm oblivious that actually such a thing is happening. I'm less incentivized to actually set it up myself and maybe put some better values than whatever is default and so on and so forth. It's
like when you have a kid and the room gets messy and you just clean it for them versus teaching them how to clean it for themselves.
Exactly. Which is, first of all, you're doing something good for your child. Second, you're avoiding to clean it yourself. It's a win-win.
Exactly. So we had five different tools, 5 different guests come on, 5 different CNCF projects. Let's talk about validating admission policy first.
Validating the one baked into Kubernetes.
We have a comment that I want to. Siraj says, but not all kids want to learn to clean the room. They prefer a clean room. It doesn't mean that's what's good for them, Siraj.
If my experience with kids, and don't misinterpret this kind of, I'm with kids. They don't mind. The parents mind much more if the room is dirty than them.
That's my experience as a parent too.
Exactly. So when I was a kid, I mean, rats could be having a whole city could be built by rats in my room, and I would still not clean it.
That's what I would have guessed for whatever reason. That rings true. Okay, so validating admission policy, Kubernetes validating admission policy, the one baked into Kubernetes. Let's talk about that.
The least capable, soon to be baked into Kubernetes. When I say soon, I mean when it now you need to enable it yourself.
It's beta right now.
Soon it will be part of every Kubernetes. So it's not as powerful. You cannot do as many things as with other solutions, but it's already there. And what it can do is very likely it might easily be all you need to do, right? So I wouldn't be surprised if in the future, when that becomes enabled by default, people will be using and then resorting to other tools more to complement it than to completely replace it. That's my prediction of the future. I'm wrong most of the time.
So validating admission policy is like a new object that's being introduced into Kubernetes. It's beta right now. There's also validating admission policy binding, so you can say where to use the policy. And what else do we need to say about it? Oh, it only does validating. It does not do mutating.
They're working on mutations as well. I was not aware of it until a few days ago.
You heard it here second. And then it uses common expression language for its to write your policy, which is pretty cool too. So that
very simple. So kind of like the learning curve itself is lower than with anything else that we're going to talk about.
Yeah. Okay. Does that segue? Let's segue into OPA Gatekeeper then, based on your previous comment. Let's talk about that one.
How many explanations do you want? One sentence?
Let's say what it is, for sure.
They're all the mission controller policies. Kind of.
They all
They
have
do
a piece of
mutations and do
software running
validations. They're all
and
they're all doing the same thing
But what
in a very
differentiates
different
it?
way.
Yeah, what differentiates OPA Gatekeeper?
The biggest differentiator is not for OPA, but for all of them, is how you define things. In case of OPA, it's Rego, right?
Rego,
So
which is
think of it as
notoriously
something
difficult
not designed.
language.
Yes.
Yes.
Think of it as something not designed to run in Kubernetes, but made to run in Kubernetes with Gatekeeper. OPA is used to all sorts of policies for anything you can imagine, and now you can run it in Kubernetes as well.
Yes. Yeah. So you might be already using Rego in all kinds of other areas in your estate, and in that case, maybe OPA Gatekeeper is a good choice for you. But otherwise, Rego can be a high barrier to entry to be able to use Rego. So if you're starting from scratch, it might not be the best choice.
It's a cult. Those who spent enough time in a cult swear by it. Everybody else dislikes it and thinks it's silly.
All right, I'll take your word for it.
I think that's a bitter laugh now from Whitney, but okay. She's getting uncomfortable.
No, I like the spicy takes. I'm here for it. Then we have Cloud Custodian, and that one is the fuzziest for me, but it seems to be something like when your resources already exist. If you're walking into a big estate that's kind of already a mess, you can use Cloud Custodian, and you could like filter resources and tag them, and then apply actions to certain ones and try to retrospectively add policy and kind of organize and clean up what you've created.
It's kind of the primary design is not that much to prevent from bad things happening, but to detect the things that were happening for a while now. So we let people for a year do random things. Let's see what did they do and who is going to get fired first. We don't fire just for you doing things. We fire for catching you doing things later.
But definitely it does like if a database hasn't been used in 2 weeks, it can detect that and shut it down and notify the admin. Can these other admission controllers do that?
Yes. So I'm not sure 100% for all of them. Kyverno, I know for sure that it can run in a kind of a cron job periodically, right?
Okay.
So Kyverno for sure. I'm not sure about the rest.
The cron job. Okay, there's something
not
that
as
I really...
a cron job, but like a cron job, meaning that, hey, run your validations periodically, right?
Again, as totally coming at this from a total beginner, this is one thing that was hard for me to wrap around my head around, and maybe I still don't get. And that is, every other context when I hear controller, there's some sort of synchronization loop. Does the admission controller have a synchronization loop in there somewhere? Or is it just triggered by that webhook?
You mean drift detection and stuff?
Yeah. Like a desired state, actual state, a controller is the one who keeps it in sync.
When you run it periodically instead of as a result of webhooks, you can say that it's kind of doing that, but it's not really controlling anything. Maybe mutation part of it would be, but
so no, it's different. It's called a controller, but it's not like any other controller. Anything else in Kubernetes, it's also called a controller.
Controller is anything that runs in Kubernetes that is managing either being triggered by creation of some resources or managing some resources. So in a way, it is mutations. I don't know.
Scott says that OPA also supports background periodic scanning.
There we go.
As Cloud Custodian, same as Kyverno. The thing about Cloud Custodian is it was not made for Kubernetes. In fact, I think when we did our episode about it, the Kubernetes support was only beta.
No, that's a tiny fraction of it. No, it's not. It's not the reason why you're going to choose it.
Yes. So then we have Kubernetes.
Write in any language that can be compiled to WASM, run as WASM inside containers. That's it. The rest is the same.
It runs as part of the mission controller as a WASM module. So, I mean, because we haven't talked about Kyverno yet, because Kyverno does it in YAML and OPA Gatekeeper uses Rego. I definitely can see a world where people would prefer not to have to write policy in either of those, especially if you're asking application devs to write their own policy.
That's completely. First of all, application devs are not going to write their own policies. That's not happening. Let's start with that. Second, I understand how YAML is not something many people like, but the response I have to that, I feel your pain, but if you don't like YAML, I think that you shouldn't get even close to Kubernetes.
You might need to consider a different career.
And finally, the good thing about YAML is that you can write YAML in 57,000 different ways, right? Define that stuff in many, many different ways and then output is YAML, right? So you don't have to write YAML. I don't write YAML. Somebody mentioned in comments Q, right? I tend to use Q for most.
So we didn't explicitly talk about Kyverno. Kyverno doesn't technically use YAML, though, for authoring policy, does it?
It's some kind of YAML abomination.
I was wondering.
It's good. I like Kyverno. Kyverno is my favorite, just to clarify. But it is a YAML abomination, kind of. Yeah.
Yeah, when we did the live stream, you were given some real spicy takes, and I'm glad to see that those didn't go away with the. So it's called what? Kyverno JSON query language that you write policy in if you're using Kyverno. And then what else is a differentiator?
Random words. I don't remember the name. I mean, it's designed specifically for Kubernetes. It works well. It's very well supported. There is enterprise version. There is open source version. It's in CNCF. Ticks all the boxes. So I would say that you probably shouldn't go for, we're in a situation that if we limit our scope to Kubernetes only, you need to find a reason not to use Kyverno rather than to find a reason to use it. Like, I don't want to generate YAML, right? Or whatever abomination it is and things like that. But it's probably the most common right now tool of the kind.
And it's also the one that the people chose. That's the one that you chose. So I believe it's demo o'clock.
Yeah. Okay, let me switch the screen. Did you put it on?
I just did.
Okay, cool. So here I have policies, Kyverno. There is one policy that we are going to use. I'm doing Kyverno simply because that was chosen.
Yeah.
And policies, right? 3 policies, all are cluster policies, meaning that they're living on a cluster level. In this case, you can see by the title, deployment has to have multiple replicas, meaning that it will be applied to deployment resources. It will be applied to the production namespace. It will be triggered only if we try to create or update, meaning not on delete. And it says it needs to have more than 2 replicas, meaning 3 and above, right, of deployment in the production namespace. Simple policy, right? Another one that says, hey, whenever you find something called SQL claim, then you should allow small, medium, and large values of the spec parameters size, right? And this one does not have namespace specified, meaning that wherever that's running. And finally, another one, almost the same, but it says, yes, but you know what? If the namespace is production, then it cannot be small. So those are the 3 policies I have here defined. And I did not use any funky Kyverno syntax here. This is pretty much YAML today. I'm not really demonstrating what I meant by abomination. So I'm going to copy that file, push it to the infra directory. That's the directory where that is configured to be monitored by Argo CD and deployed. Something will be deployed soon. Not something, Kyverno in this case. So I'm pushing it. I'm committing it, and committing it, and now pushing it to Git. Now what I forgot to do, port forward. I'm going to forward the port just so that I can show the Argo CD UI. localhost. There we go. I'm realizing that I'm not in the right screen. There we go. Admin 1, 2, 3. There we go. Now this is too small for me to see on a tiny teleprompter. There we go. I still don't see, where is it? Infra, there we go. You will see that, okay, it is already deploying Kyverno and the policies, and that's ongoing. Cool. So I should have policies here in a moment. And now let's take a look whether that's working. kubectl get cluster policies. Come on. I know what's wrong. I need to stop the... no, stop the port forward and then kubectl get cluster policies. And there we go. One is there. The other two are not. They will be there soon, probably, hopefully. Let's say, maybe. Let's go back to Argo CD and see what's wrong. Come on, refresh it. It will be deployed, probably. I mean, if I'm gonna kill myself if I failed at the very beginning.
Oh, no.
Yeah, it will be there. It will be there, eventually. Oh, I see. I have a leftover from before. Let me remove it. RM. This was not supposed to be here, and this was not supposed to be here either. This is for the next.
I was just going to say we're doing observability for our next chapter, so it looks like you're starting to...
part, exactly. You already sniffed what's coming up. I actually orchestrated this so that Whitney thinks that I'm working on it, kind of. I'm faking it, really. Let's see whether now it's working. No need for that. Sync status. I'm going to terminate it. Start synchronize again, just not to wait. Then Kubernetes dashboard disappeared. No, it will disappear, probably. I don't know.
I'm going to acknowledge a couple comments. Frederick is here. Hi, Frederick. I still think of yams every time I hear YAML. I didn't before, but now I will. And Scott says the reason to use OPA Gatekeeper, presumably, is that many tools and platforms have it included with support.
Yeah, exactly. That's actually a very, very good point. That OPA is kind of a standard, right? And yes, there is infinite number of tools that support it. What is also true is that there is a huge number of tools that support YAML in Kubernetes, right? So same can be said for Kyverno, one way or another. And while we're talking, I'm realizing that there is something wrong. Those two policies are not working. I will figure it out. I don't need really. I don't need to wait, because the first of the policies I can demonstrate easily, and then the rest does not matter, right? So I'm going to. What am I going to do? I'm going to execute this. It will update my settings file for later. Not really important. What does matter is that I'm going to push my application, right? Argo CD, CNCF demo. What did I use? I forgot. Did I set up YTT? I think customize. Oh, I use customize today. I don't know why I did.
No.
I was supposed to use. No, I know. You see that I'm completely messed up with. And I have a dashboard, Kubernetes dashboard there, and nobody knows what I'm doing. I just try to get ahead from what's coming next, so that might be causing issues. Git add, git commit, something, git push. There we go. And now our application should be running very, very soon. So let's double check. kubectl namespace production get services. Let's say services. They should appear. They're not appearing because Argo CD probably did not synchronize it yet. We can check that. There we go. Make it bigger. Oh, I'm not doing port forwarding. There we go. Oh, okay. Argo CD. Application is here, and yeah, now it should be there. It should be running. There we go. Okay, so let's double check whether services are there. Services still not there. Okay, let's talk about the next section to see how did I confuse observability with
With security.
Mm-hmm.
The reason I'm giving Victor a hard time for using customize is because you, the people, chose Carvel YTT back a long time ago in chapter 1, like a year ago. And that's what we should be using. But that's okay. It'll get done. Yeah. Should we stop sharing your screen now? Or
yeah, you can stop sharing my screen. Yes.
But so those of you who watch regularly probably know when Victor's demo doesn't work, he checks out because he can't think about anything else until it does work. So this is
yeah, I know what's wrong. I know what's
You figured
wrong.
it out?
I forgot. Yeah, I figured it out. It will happen. I need 5 minutes to fix it. It will happen very, very soon.
Okay.
Let's go to the next section.
The next section is runtime policy. So runtime policy is what you need to implement so you could be adding policy, first monitoring, alerting, and maybe preventing stuff that happens when your application is like during execution. So you're securing against unknown unknowns at runtime. So with Falco, it's a graduated project. You make Falco rules where you define conditions. And if these conditions happen, then it triggers an alert. And the alert is just a text that has a priority associated with it. And then there's Falco sub-projects. So there's Falco Sidekick, where if you can forward that alert to many compatible destinations. There are like 50 or 60 of them. So you could do it to Telegram, to email, to Slack, whatever. And then the other thing you can do is Falco Talon. And Falco Talon, you can actually take action on an alert. So that action happens after the alert, and it can be something like kill a container or start collecting information, more information. So that's Falco in a nutshell. It's heavily used, and it's been around a long time. And then we have, I'll say one more thing about Falco. How it collects events. It has system events and plugin events. So system events can be collected either with there's a kernel module, there's also an eBPF probe. And so you're working with system calls really. And then your plugin events are like cloud provider plugins, Kubernetes plugin, gvisor plugins. So I think there are 13 different sources. And that's just reading logs from different places. So that's how it's getting all of the source information. So that's Falco. Did you hear? How much of that did you hear? And do you have anything to say?
That's Falco.
I was full tuned out. That's cool. I have it right. And then the other side of that, the new kid on the block is KubeArmor. So KubeArmor uses eBPF to hook into the Linux kernel. And it's also monitoring calls at the kernel level in a secure and performant way. And so it does the same. You monitor, you can alert, but then it also does prevention. So with this, when an attack is attempted, it fails. So it never happens in the first place. And it does that using LSMs or Linux security modules, which are access control modules to the Linux kernel. And it's looking at both of these when it's looking at the system events or looking at events like files being opened, permissions being changed, network traffic, something being executed, those sorts of events. I think I just said it all, Victor. Does anyone have any questions or comments? Victor, you're muted.
I'm saying I'm almost there.
Okay.
Almost. We'll see. We will all fail miserably eventually anyways.
And another thing I'll say is they're not mutually exclusive. Like I believe that KubeArmor is working on being compatible with Falco Sidekick. So KubeArmor alerts can also get forwarded to different destinations. And then both projects can supply recommended policies. There are Falco rules. I think there are like 70 Falco rules that have kind of been figured out by the Falco community. And KubeArmor can also supply recommended policies based on industry standards. Basically, watching
Yes,
kernel.
I agree.
Yes.
I'm almost there.
When Victor tunes me out, instead of taking it as an insult, I take it's flattering. He has full confidence in me.
That's what you think. But that's one explanation. Another explanation. Look at my camera also died. This is such a great day. Okay, let's switch to this one. There we go. Such a great day today. Okay, so let's see whether it works. Can you share my screen again?
Yes, absolutely.
We're going to do this. Where was I previously? I was doing Kyverno. Yes. So here we go. kubectl get cluster policies. And now the 3 cluster policies are there. Yay! And I deployed my application by error using customize. I will repent for that later. What does matter is that some things, like if I do -- namespace production get services there. But if I do deployments, the deployment is not there. And the reason why it's not there is because Kyverno did not allow it to happen. And I can confirm that. Look at that. This is now output from Kyverno. This is now taking a look at the deployment production policy from Kyverno that says, no, Victor, you're a horrible person. You cannot do this, right? So I need to fix this. And the key is, again, by error, if I go to customize deployment scaled YAML, this is the deployment I should run, right? Not the deployment that has only one replica, right? So I'm going to add this this overlay to my application. Here, I'm just saying add that file to the patches of the application. I'm going to add commit and push. And then a few minutes later, not few minutes, I think that I set Argo CD to 1 minute. When it figures out that there is a change, and I can speed that up by going to Argo CD and saying, stop what you're doing. Now you expect me
Do you want to
see
show us?
what I'm
Okay.
doing. There we go. Stop what you're doing and try again, right? Refresh. And then if it refreshes, let's say that it succeeded, which might not be the case. If we do the get deployments, still not there. But I got further away than last time. So this is a big success. This is a big success for me. Don't be yes.
So it failed because you didn't have
enough.
enough.
Sure
yeah.
is, let me just double check. Did I push my changes? Status. I did push my changes. Did I? Let me check. Customize overlays prod customization. Did I change this one to use the deployment scale? I did. Okay, so it is definitely something wrong with Argo CD. I'm going to try it one more time without showing it on the screen. If it fails, then we're going to move on and sing Kumbaya. There we go. Okay.
We can't.
Let's see. Production apps. You cannot see it because I don't want to show you how badly I'm doing this. Customize build path to cache source customer failed. I'm seeing some failures. This is going terribly wrong. I'll be back while Whitney explains the next section.
Oh no.
Yes. You can leave the screen if you want to see what I'm doing, but there we go. But it's not going well. Not going well at all.
I was just thinking there should be a library of Kyverno policies that's just like super duper extra insulting whenever you violate a policy. Just like people like to go to those restaurants like Dick's Last Resort where they make you wear a hat and they make fun of you the whole time. It's like a roasting.
Probably.
So the next one we talked about is secrets management. Victor, I don't want to do this without you. It's more fun when it's a conversation.
Yes. I just don't know what I did wrong, and I need to figure it out. Probably, it's complaining about this file, Argo CD. Let's take a look. Vim, this one, no. Cut, customize, overlays, prod. This file, there is something wrong with it. Nobody knows what's wrong with it. Already registered, blah,
It has
blah, blah, path to
a
cache.
size small, which violates the policy. It's not allowed to be small, right?
Yes. Oh, yeah. Let's take... No. No, you're wrong, Whitney.
Okay.
It should let the deployment come in and not let Argo CD freak out. Yes, I messed it up completely. This happens.
It does happen. We're human.
Yes, it does.
Cool. We're just going to watch you work it out for a little while longer. So tell me right now what the problem is. I got a little lost.
I would love to tell you if I would know what the problem is, but I honestly don't. Here is Argo CD complaining that it cannot do anything, and it has one warning. And if I keep it on the screen, I don't see it because I'm looking at teleprompter here. Pet to cached customize overlays prod failed exit fetching. Please use patches instead of customize edit field. I think that I'm using old version of customize. That's what's probably wrong. I know what I'm going to do. Okay, I have a great plan to fix it all.
Are you going to use Carvel YTT?
2 minutes. I'm going to use Carvel YTT exactly as I was supposed to use it all the time, right? There we go. That's what I'm going to do. Carvel YTT to the rescue. Here's one. I think I'm probably doing Carvel YTT. I'm going to do the things that I normally do in the setup. There we go. And YTT, few more things. Here we go. And few more things. Boom, boom, boom. And I'm going to take a look at apps, CNCF demo, which right now it is using customize, but we're going to change that to use YTT, and then everything will be fixed. And I know at least one person in the audience that is going to be very, very happy for this, right? At least one. Here we are. There we go. Okay.
We can't see what you're doing anymore. Okay.
You don't see. There we go.
Okay.
I'm going to change YTT. I have a values file, values pro, that contains the number of replicas to 3, and that will generate a file. And this is the file that the files actually. This is the files that it will generate. And one of them says where it is: deployment. Now it's set to 3 replicas, right? And exactly. And I'm now going to have to change Vim apps CNCF demo. I'm going to have to change this one so that it is pointing to the YAML prod directory, right? That's where we keep YTT files or output from YTT. I'm going to push all that to Git, and then I'm going to port forward to Argo CD. And where is Argo CD? Argo CD is here. I'm going to say refresh, and then it will still not work. And then I'm going to kill myself if that's the case. No, I'm not going to kill myself. Don't worry, Whitney. There we go. I'm going to delete the application.
Are we meant to see Argo CD, or are you hiding it from us?
Yes, I'm hiding so that you don't see my incompetence. There we go. Argo CD. Now it might work or no. There we go. Woo!
Hey!
Okay, I should have used YTT from the very beginning. That's the lesson learned.
Awesome. Okay, so what's this got to do with Kyverno?
what that has to do with Kyverno is that now, if you take a look at where was I? If you take a look at the deployments, because I changed the number of replicas to be 3, now it allowed Kyverno allowed deployment to be created, right? Because now the rule is met. It has 3 replicas. That's great. Now, if you take a look at the pods are not being created, but that has nothing. You see, create config container config error. That's because pods require a database secret created as a result of creating a database, which we are creating right now, or we should be creating. But if we list all the SQL claims, this is now with Crossplane, the database was not created. And the reason why the database was not created is because we have 2 rules in Kyverno, right? If you remember, one that says small, medium, large, and the other one that says anything but small if it's a production namespace, and we are running in production namespace. So if I take a look at the first rule, no problems here. It says, yeah, you can do it, right? Because the size of the database is set to small, right? But if we take a look at the second rule, there we go. You will see now here it says, no, Victor, you're still an ass. Just slightly smaller than before.
It's a different.
Yeah, different type, right? So I need to change that. And I'm going to do that by changing again the values file that I have for YTT. This time it's going to change the database size to medium, right? And I'm going to generate YAML files with YTT, because as far as I know, you cannot instruct Argo CD to use YTT directly. You output it to pure YAML, and then Argo CD does whatever it's doing. And now, if you look at the database SQL, where is the SQL? Database, no, SQL claim. Now it says medium, the database, right? So I updated my my database, and now if I push it to Git, and if I output all the claims, you will see that there is still no database, but that's most likely this time because Argo CD did not find those changes yet. So I'm going to speed it up, port forward. I'm going back to Argo CD. There we go. And I'm going to stop whatever it's doing right now. And I'm going to tell him, yeah, go to Git again. Find out what's going on. And you will see that some additional things appeared on the screen, and it continues appearing. And that means that this time Kyverno let it pass. And we can confirm that. Here we go. By saying, there we go. Now it allowed it to pass because it matches all the rules and all the schemes and all the stuff that was supposed to happen, right? Now, this will take a while. And I think that if I was listening, I would not have to guess that you already explained Falco and
I did.
What's the other one?
Kubearmor.
Kubearmor, yes. You already explained those two, right? So we need to go now through those. And
yes.
What did we choose? What did people choose? Kubearmor, was it?
Yes, right? The people chose Kubearmor. Yes. Yep. Mm-hmm.
Oh, I'm so impressed by myself for paying attention. This is absolutely freaking amazing. This is so cool. I'm going to execute this script that sets it up, right? Just installs with Helm and all the stuff, boring stuff. No need for me to type it wrongly and make a mistake. Basically, I'm now using... Kubearmor is a bit messed up because there is no Helm chart, right? You can either install it directly through CLI or output thousands of lines of YAML and store it to Git. I don't like either of those two ideas. But so I'm not using Argo CD to install it. I'm using what am I using? I executed Karmor, blah blah blah, install this stuff, right? And that's being installed right now. And this will not take long. This will take probably I don't know, 10 more seconds, something like that. Normally, in other situations, I would say. No, actually, I did generate YAML and push it to... Yes, this is now being in hands of Argo CD, which will deploy it soon.
So for those just tuning in, what are differentiators between... What is runtime security? What are differentiators between Kubearmor and Falco?
Yes, so Falco depending on the rules we set and all that stuff.
Yes. What's runtime security first?
Runtime security. Okay. Figure out what's going on security-wise at runtime, meaning inside the cluster, right? So it's not, the goal is not that much to prevent things from reaching the cluster as it's preventing from bad things happening when stuff is already running. This is my childlike explanation, right?
Yeah, I'm here for it.
So while admission controllers are on the API level, this can happen, this cannot happen. This is, okay, but now that it's running, let's see what's happening, right? Whether something is happening, it shouldn't be happening. So that's the major difference, right? And then if you look at Falco, Falco will give you very, very detailed information about when something is that something is happening, it doesn't match your rules, right? Kind of, oh, this request is sent through the network and that's not matching the rules of the things that are allowed. Or, hey, this process was just spun up. This started running and it shouldn't be running, and so on and so forth, right? So it is giving you the reactive depression, right? You will find out that things are wrong, and then you're going to freak out and try to figure out how to fix them. And it's very, very useful. Now, K-Armor is less into giving insights of what is going on, even though it can do that, and more about do not allow this thing from happening in the first place. And this is Mac going crazy with balloons. Anyways, do not allow this thing to happen, right? You cannot execute any process from or any binary from this directory. Only binaries from that directory can be executed. You can make requests only to this address and not that address and stuff like that. So think of it: Falco insights, K-Armor prevention from things happening, right? So with Falco you will find out the things that shouldn't be happening are happening. With K-Armor you will prevent things from happening. You probably want to combine both, because very often you cannot know in advance, oh, if I knew this, I would have prevented it. I would have created K-Armor rule that denies that from happening, right?
So in runtime policy, the first step is to monitor your application and have a clear idea of expected behavior. And that's what you need so you can make policy. So if anything unexpected happens, then do something.
Exactly. Now, let's say that what I'm going to do is that I'm going to enter into this pod, a container inside of this pod. I'm going to execute ls. It's a silly command that just lists files in the root directory, nothing really special. But what is special is that I'm allowed to do that, right? I entered into container and I executed the command ls and I saw all the files there. Now, what I'm going to do next is annotate the namespace production and say, hey, the Kubernetes file posture is block, meaning that it can be inform or something like that. I'm not sure what's the exact name, but it can inform you of things. It can block things. I want to block stuff inside of that namespace, and I'm going to apply. Here I have a definition of a K-Armor policy that says, basically, it's a very simple one that says when you find there is a file, any directory, root directory, and anything inside of that root directory, if the process is not /manager, if process is manager, then allow it, meaning that everything else, because of the notation I did before, is not allowed, right? So policy says this is the only thing that can execute inside of that container where I was before, right? Where I executed ls. So what I'm going to do is copy that to the infra directory, push it to Git, and then a few moments later, Argo CD will apply that policy, right? Now it's not there. It will be. I know you're impatient. I'm going to, here we go back to Argo CD and refresh it. Applications, let's make it bigger. There we go. And I'm going to go to infra and say refresh, right? And it will find out that change. And hopefully we should now have here the KubeArmor policy. There we go. There's the policy, right? Argo CD synchronized it. I speed it up a bit. Now, what does matter is that if I go back to the command, what was that?
ls.
Not that one, this one, ls, right? If I go back to this command, there we go.
Denied.
I cannot execute it, right? I'm not allowed to run that thing. And that's basically that's it. That's what there is. That's what it does.
That's KubeArmor. Yeah. Cool.
That's KubeArmor. And now I'm going to change the battery on my camera while you're telling people about the next one.
Victor. Okay, so we're talking about, you can hear me though. Yeah. We're talking about secrets management, and there are 4 tools for that. We have external secrets operator, secret store CSI driver, SOPs, which stands for secrets operations, but if you call it secrets operations, no one will know what you're talking about, and tellers, the last one. So let's secrets.
Yeah, I'm back.
You're back.
Stop. It's completely messed up. We're gonna go for webcam. It's fine.
We're getting the real Victor here with the not even the purple lights in the background anymore. This is like
no lights.
Yeah,
nothing.
everyday Victor. So Secret Store CSI driver has come up with a way to get, so basically secrets management involves secrets rotation, remediating when secrets leak, storing and distributing secrets. But most of that stuff is done with a vault. And a vault is a technology that at its core does 2 things. It stores secrets safely, and it has an API to interact with it. But it probably does a lot of those other things too, like remediation and distributing.
Just clarification,
rotating.
when you say vault, you don't mean HashiCorp vault, you mean any secrets manager store, right?
That is a wonderful point. Yes. A vault technology, not HashiCorp vault. And then, so we already have that solved with the vault, and a vault is not one of our system design choices here because there are no vaults in the CNCF as far as I know, as far as either of us knows.
Not that I know.
So our secrets management problem that we need to solve is how are we going to get secrets from vaults or just secrets period into Kubernetes? That's the problem we're trying to solve. And so secret store CSI
and it
driver
have to be in vault.
Yes.
One of the choices assumes it's not in vault.
Yes. In fact, one of the choices, which is SOPs, spoiler alert, is like, hey, sometimes the vault's too much and you just want to bring a secret right in without having to use a vault. That's what SOPs is about. In fact, let's just skip ahead to SOPs. We'll talk about that one first. So that one, SOPs, all it is a CLI that encrypts and decrypts files.
Correct.
Yeah. So you can take the secret part of your file, encrypt it with SOPs. Then you have it, whoever you give your decryption key to can therefore decrypt your file. And in a GitOps workflow, what does that look like?
In GitOps workflow, it does not look pretty.
No.
That's how it looks like. Basically, since there is no, if you exclude, I think it's called KSOPs or something like that, there is a SOPs operator that accepts only customized.
It can generate customized secrets, I believe. Yeah.
Exactly. You cannot just instruct Argo CD to synchronize some type of SOP specific resource because that thing does not exist, right? So Argo CD, you need to instruct Argo CD through a plugin to say, hey, if the file is this, then you should execute this CLI command and transform that into YAML. Before that, get encryption key and stuff like that. And then somehow create that YAML, and then Argo CD can do whatever it's doing, right? Apply that YAML to the cluster.
So in a GitOps workflow, you encrypt your file, and then you can check it. You can safely check an encrypted file into Git, which is cool. And there probably are some use cases for that in terms of just sharing a secret among teammates or something. But the case of Argo CD sees that it has a file that's encrypted with SOPs, and then you teach Argo CD with a configuration management plugin what to do when it sees a SOPs encrypted file. And then it does those things, and it gets the decryption key, and it uses it, and it decrypts it, and then it can apply it too. So it seems, I think it's better with Flux because of KSOPs, because Flux is more tightly integrated with Customize. Is that true?
Not only that, but simply Flux supports SOPs natively. Basically, what you would do with a plugin, Flux does. I mean, Flux is still executing behind the scenes SOPs and all that stuff. There is no way around it. Maybe through code instead of CLI, but it's doing the same thing. It's just that it's baked in, so you don't see it.
So there are some decent use cases for SOPs, but in terms of our choices, because we've already chosen Argo CD, it's maybe not the best, is my understanding. Yeah.
Yeah.
So that's SOPs. And then we have Secret Store CSI driver, and their idea is Kubernetes secrets aren't safe. So we're going to come up with a workaround so we don't need to use Kubernetes secrets at all. What's your take on whether, do you want to talk about the safety of Kubernetes secrets?
So the biggest unsafe thing is that all the resources in Kubernetes are stored in etcd. So whatever you create it's in etcd. And if etcd is not encrypted, you have potential vulnerability over there, right? Now, whether it's encrypted or no, that's up to you or to a cloud provider if you're using managed Kubernetes. So it's kind of more or less safe depending on whether etcd is encrypted or no. And also there is potential there are other ways you could actually get to that secret. But the way I see it is, unless we convince most of third parties not to use only secrets, there is no way avoiding it, right? So you can say, okay, I'm not going to use secrets for my applications, but then I'm going to run, I don't know, MongoDB as a chart, and MongoDB is going to generate a secret, or something else is going to assume.
And when you say a secret, you mean a Kubernetes secret, yeah.
A Kubernetes secret, or you're going to use something else that requires you to provide it with some confidential information, and and the only way to input confidential information into that third party is as a Kubernetes secret, right? So the biggest problem with that, actually, I think the idea is really good, but the only biggest problem is third parties, right? You will not be able to have a cluster without secrets, unless you start forking charts and modifying them and so on and so forth.
Yeah, that's a lot of downstream work. So Kubernetes secrets.
What Surai is proposing is actually would be correct, right? If you would have a CNI-like interface for secrets, then hey, it looks like a secret from the Kubernetes perspective, but it might not be a secret depending on the implementation. That would be awesome.
That would be awesome. So I want to back up and give more background information for other new folks like myself. So Kubernetes secret is just base64 encoded and stored in etcd. So that's not great. But you can add technology to your cluster that encrypts secrets while they're at rest. So then they're encrypted at rest and they're encrypted in motion, which we'll talk about in next choice. And then secrets are only sent to the node that needs them. And then as soon as the process on that node doesn't need a secret, it's deleted from that node. And also, while it's on the node, it's only ever in temporary file storage. It's never written to disk. So, people say that safety of Kubernetes secrets, there is none. Suraj has that in the comment too. Like, I'll say there's some. Maybe it's not foolproof, but there's some effort made. It's not nothing.
The point is that if we don't, as a community, if we don't feel that that's safe enough, and I would agree with Surai on that one, we need to rethink how Kubernetes works rather than do some workarounds, I think.
Okay. And then the Secret Store CSI driver workaround. So it's a SIG auth, Kubernetes SIG auth subproject. And it is it uses the CSI interface, the container storage interface, to mount a volume to your application pod, and then pull a secret from the vault and then write it directly to that volume. So there's never a Kubernetes secret, and now your application can access the secret as part of its own file system. So
Correct.
to repeat what Victor said, that's pretty awesome, except that all the different third-party tools you're going to run in your cluster are relying on you to have Kubernetes secrets. They're not going to know how to interface with they're not going to look in their own file system for a secret. And so therefore,
Correct.
it's not the best choice for that reason. But a cool project nonetheless. And I do like Suraj's idea a lot too. And then we have Teller. What's Teller, Victor?
Teller is nothing to do with Kubernetes, yet the project that I use every single day, multiple times. It's basically a CLI that allows you to fetch secrets from some secret store vault and fetch them in different ways. It can be as environment variables, it can be a source file, there are many different ways you can fetch them. When I work locally on something and I need some secrets, I just use Teller I have a .teller file that defines how to fetch the secrets I need, but without the credentials, I can safely store it in Git, because I'm not really giving you the path to the secret, but without access to that secret, so it's relatively safe.
Cool. And so my understanding too is it helps with if you have a ton of different secret stores, like in a multi-cloud situation, and every cloud has its own secret store. Like you now have like this centralized place that you can use to access your secrets instead of trying to connect to everything separately. And then it's never exposed in plain text in your terminal too, right?
Like one good use case for Teller would be, apart from my laptop, would be pipelines, right? Or basically anything that is not Kubernetes.
Cool. And then we have external secrets operator. So external secrets operator is a Kubernetes operator, and it connects to your Vault API, pulls a secret from the vault, and then makes a Kubernetes secret with that secret. And then it manages the lifecycle of the Kubernetes secrets. And then it does the flip side, where it could take a secret that's already in Kubernetes, if this is an alpha feature, and it can take it and push it into a vault. And it can also generate secrets, Kubernetes secrets for you.
Yeah, that's the part that is really awesome. Probably for many people is not needed, but we tend to generate secrets, not only to consume secrets, and being able to store those generated secrets somewhere is absolutely amazing.
Cool. People do love external secret operator. So, and speaking of, that's what the people chose. So let's get on with the demo. Here we are.
The downside of you telling me pay attention to the conversation instead of doing things in the background is that we need to wait for a couple of seconds now.
Oh, that's okay. Do you have anything you want to add to my description of external secrets operator?
No, it's I feel that it is the most commonly used generic secret operator, right? I mean, it's actually saying generic because a lot of people who are using exclusively HashiCorp Vault might opt for Vault operator or whatever is the name that does something very, very similar, right? But if you want something that is more neutral, that works with any type of secrets, that's about it. Now, speaking of that, let's do this. Now, if I output right now the secret that I have for my database, you will see that this is the secret right now. The problem with this is that if I would show you the manifest, you would see that this secret is in my YAML right now, right? That's the root password for the database in RDS AWS database that I created before. Very bad idea. If you go to my repo right now, Devos Paradox/CNCF demo, you will find that password. If somebody from my company would be watching, I should get fired. Now, I will change that. And the way I'm going to change that is that if I take a look at my application right now, that's the bytety YAML that I specified. There we go, right? This is my password. base 64 encoded. So you can find out what it is just by executing base 64-d, right? What I'm going to do is that I'm going to delete my application completely. We're going to start over. And I'm going to push those. So I deleted my application. I'm pushing it to Git so that Argo CD figures it out. It will delete the database, and because I just told you where my Git repo is, you should be able to access the database easily. And after a few moments, my database should be gone. Now a database is created with Crossplane. You should see manage resources here in a moment. I'm not going to wait for that. Instead, we're going to work on customizing the solution to use external secrets, right? And since I'm using YTT, I'm going to say yet another variable that I'm going to say insecure is false, meaning that I want secure database. You will see the output of that in a second. I'm going to generate the YAML. There we go. And now if you look at that YAML, what will happen? So secret is gone. I don't have a Kubernetes secret with hard-coded secret. What I have is external secret that uses cluster secret store, meaning that that's the type of resource for external secrets that defines how it can access, like credentials for external secrets to access my database account. And it's going to create Kubernetes secret called cncfdemodb password. And it will create it by extracting the value from secret in AWS Secret Manager called production PostgreSQL, right? And let's see whether my database was deleted. Actually, yeah, let's take a look. If not, we might need to wait for a moment until all the resources are gone, and then I'm going to push it to Git, and new database will be created with the password that you cannot find out because it's not in Git, right? It's somewhere else. It's in AWS. So my database is still not created. It will take probably a couple of minutes until database is gone, and only then I will be able to push it to Git. And until then, we can go to the next section, if that sounds good, and then catch up.
Sounds good. Should we pull the screen or leave it on? Are we watching it?
Yeah, I'm watching it. We can pull the screen. I'll tell you when to put it back.
So the next episode is episode 4, and we called it Network Policies and MTLS. But now that I've learned more about all of this stuff, I don't think that's a very good name for the episode, because network policies are a specific kind of Kubernetes policy, and really all we meant was authorization policy. And MTLS isn't even, Cilium doesn't use MTLS. It does. So long story short, I think the episode in perfect retrospect, no MTLS, spoiler alert. In perfect retrospect, it should have been called Secure Pod-to-Pod Communications, in my humble opinion. And so there are 3 aspects of securing pod-to-pod communications. One is that the pods need to have identity and be able to verify each other's identity. 2 is that the connections between the pods need to be encrypted. And so those 2 together can be solved with mutual TLS, but they don't have to be. And then the third thing is we need policy that says what pods are allowed to talk to one another. And with those 3 things together, then we can secure pod-to-pod communication. So this episode, we talked about all the different service meshes or service mesh-like technologies. So we talked about Istio and Linkerd, also Kuma. And then we talked about some outliers, which would be Cilium and Network Service Mesh. Because they all work differently. It's quite a beast of an episode, actually. I didn't know what I was walking into with that one. And so let's maybe talk about the sidecar, the application level, layer 7 sidecar service meshes.
So
Technologies.
I can give you the pitch for sidecars in general, right?
Okay.
Sidecars are very useful way to extend the functionality of container essentially in a pod with additional capabilities. And in case of service mesh, that's networking, but there are many other use cases for sidecars.
Yes.
Now, so because sidecars allow us to attach additional processes to the main container, main process. And that's true until we discovered the usefulness of eBPF.
Right. But we're not there yet. Yeah.
Ah,
We're not talking about that yet. It's too soon.
oh, yeah, now I see that I'm not following the script.
We're telling a story. We need to leave. So sidecars can be called proxies, can be called the data plane, and in general, this type of service mesh that's could also all the sidecars together could be called service mesh. It can add. We're talking about it from this angle of securing pod-to-pod communication, but it also adds, besides security and networking and observability, to the cluster. So basically, at the very beginning, when we talked about cluster level policy, we talked about service meshes and how sometimes they're going to inject an extra container, a sidecar, into every pod. So every workload pod now has a workload container running and an extra container running. And that container, what it does is it's a proxy. So every request that's meant to go to the workload now goes to this proxy, and then the proxies request to and from the workload container. So the idea is you don't want your observability and your networking and your security you don't want to have to hard code it into your application. You can outsource all of that logic and put it with all these sidecars called the data plane. So then the service mesh technology, and this is Kuma, Istio, and Linkerd, it gives you a friendly control plane like Kubernetes resources, or ways for you to be able to define what you want your data plane to be doing. And the data plane is all the proxies, and they do the work of actually routing their requests. And different technologies can be the data plane. Anyway, it's a lot. So thank you, Victor, for letting me say all of that stuff.
I don't know. To me, that's all still very, very confusing. So
I didn't. I made it worse instead of better.
Who knows?
Who knows? I drew it all out. We did a KubeCon talk with securing pod-to-pod communication being one of the choices. So I do have an illustrated version of everything I just said. But basically, we have this sidecar way of doing it. We have the Cilium way of doing it that I stopped Victor from saying. And then we have the network service mesh way of doing it. So what's the Cilium way of doing it? What is Cilium, first of all?
Cilium is a CNI first and foremost, right? It's
what's a CNI?
Something networking interface.
Container
networking interface, most likely.
Yes. And it's yes.
Get a B. Yeah, so it's a networking interface, right? And you cannot really effectively use Kubernetes without a networking interface. And in the past, if I'm not wrong, there was some rudimentary CNI-like baked into Kubernetes. Now you need to choose it now, kind of. If you set up Kubernetes yourself, instead of using a managed Kubernetes, you need to choose a CNI. Nothing to do with service mesh. Service mesh comes later on top, right? Just pure networking communication between pods and discoverability and all that stuff.
What I learned about CNI, it does more than this, but at the very root level, bare minimum, it helps the kubelet assign an IP address to a pod. So and then it gives a networking stack, but I like the simplicity of thinking of it that way. So without a CNI, a kubelet doesn't know what IP address is available to give to a pod and how to make it discoverable to all the other pods. And we should say CNI implementation every time we say CNI, but that's not what the people do. Yes, so CNI is a specification, and Cilium is a CNI implementation.
CNI, yes.
So Cilium is the CNI implementation. There's not really another one that that can compete, is there?
Another one that can compete
Yeah. Calico?
as a CNI, yes, that would
Yeah.
be Calico.
Yeah.
I mean, compete. I think that Cilium is way over in terms of usage, way higher than Calico. But if the question is there an alternative to Cilium? Yes, there is Calico. Should you use it?
But like, yeah, if you're provisioning like a managed cluster in like Google GCP or something, you just have to press a button to have Cilium, as opposed to like it's not even. It's a choice. It's very commonly used. I want you to with me, Victor. Should I just show the screen? Should we lean into this?
Yeah, I'm just trying to figure out why now my application is not working still. Now it's again source path. I mean, I don't know what I'm doing. I think that 1 hour is my limit. I'm doing something wrong. I'm not sure what is that wrong. I need to take a look at Vim apps application. Oh, here's the problem. You see this field? That's wrong. This field should be gh-repo view --web. This is the repository here. That's the repository. I somehow messed it up, so I'm going to fix it. Repo URL. Here we go. Maybe I should put HTTPS at the beginning. HTTPS. What am I doing now? Okay, again. Okay, HTTPS. This is my repository. I don't know why it disappeared. And then if I add it to, now it will probably work. kubectl port forward, and now my application should be working. If I refresh it, something else will fail. No, yeah. Now my application is working, is being synchronized. And if I go back to what we were talking about, yes, we were talking about external secrets. If I show you the what's the kubectl dash namespace production, there we go. External secrets, it should be, there we go, right? So this is now external secret that is went to my AWS account, fetched a specific secret, and it created kubectl production. It created this secret here. Key secrets. There we go. There's the secret that was created by external secret. It works. We live happily ever after and all this stuff. Yes.
Excellent. So we're talking about securing pod-to-pod communications, and we talked about doing it at L7, the service mesh level, where we inject proxies into it. And when the proxies are in our workload, in our pods next to our workload container, they add identity and encryption with MTLS or mutual TLS with certificates. And then you can add, as part of the service mesh, you can add policy about which pods are allowed to talk to one another. Correct. So now we're talking about Cilium and CNI implementation, but we haven't said how that relates to pod communication. First, I want to say Cilium works. So the kubelets will ask Cilium, hey, I need an IP address for a pod. Cilium gives that IP address to a pod, but then Cilium also gives that pod an identity, a spiffy identity. And then Cilium also attaches an eBPF program at the pod network namespace. And that program generates events for every little thing that pod does. So now we're capturing every single event that the pod does at native kernel speed. And so that eBPF program that's running at the kernel level, that's unique to a pod, is how we're able to encrypt. So we added identity with Spiffy. We encrypt in communication with either Wireshark or IPsec. Now with Cilium, those two things are decoupled. And then we can also add policy about which pods are allowed to communicate with which other pods. So it solves these three things in a very different way than doing it with the proxies or the sidecars. Does that. What else do you want to say about Cilium? Nothing. Okay. You're muted. And then you're I said you're muted.
There is a strong chance that it is in your cluster. I think that's important part for whatever comes next.
That is a very good point. So as you've said before, cluster, by the time it's running workloads, it already has a CNI in it. And so there's a strong chance you're running Cilium just because it's so ubiquitous. And if you're not running Cilium, you can't really add it without tearing down your cluster and making a new one, right? It's pretty...
it will be tough to change CNI. Not impossible, but tough.
Yeah. So that's a big deciding factor, which we, for our demo cluster, already do have CNI. Cilium as the CNI.
Cilium, yes.
Yeah, cool.
It's already there.
It's already there. And then the other technology that we talked about during this episode is network service mesh. And so I haven't thought about network service mesh in terms of those three things about securing pod-to-pod communications. But what network service mesh does is it's a service mesh that it connects workloads on layer 3 of the OCI interconnection model, which is layer 3 is the packet layer. So it's like the IP layer is what it's being connected as. So what it can do though is connect workloads across clusters or across environments and then have those be in secure connections without the connection having to happen from within a trusted network. So it's a good solution. Like if you're a car company and you heavily interact with a certain supplier, so much so that your services need to be able to trust one another as though they're in the same domain, you can create a network like that. How do you feel about that? Frederick, are you still here?
I feel that when people start saying this layer or networking or that, I start counting on my fingers how many people know all the layers, really. Like what every single layer does.
That's true. I think though L4 is like sockets or something, which I never hear anyone ever talk about sockets. But it seems like it's cool and it definitely has its use cases. But like you couldn't have a Linkerd proxy talk to an Istio proxy if you were trying to interact with another organization. And so that might be a good idea, like a good way you could have your services connect by doing it at that IP layer and doing it with network service mesh. So that's all the choices. We had 4, right? Cilium, Linkerd. Oh, yes. Yeah, we had 5. Kuma. So Istio, Linkerd, Kuma are all the sidecar model. What differentiates them from each other? Istio does everything, literally everything. And then Linkerd, and it has Envoy as its proxy layer, as its data plane. And then Linkerd does almost everything, but it's a little lighter weight. It might be a lot lighter weight. Linkerd people say, so they have their own custom written Rust proxy, and Linkerd people will say it takes up 10% of the resources as the Envoy proxy that Istio uses. And Istio will say that used to be true years ago, but these days it's about the same. I don't know who to believe. But Linkerd does less stuff, but then you do have operational simplicity. It is easier to use. And then it's performance and retains advanced functionality. And then there's Kuma. And Kuma is about, it calls itself the universal mesh. So it can be run as a sidecar, but also as an operating system service. So the idea is that you can incorporate VMs and incorporate physical machines as part of your mesh. And that's what differentiates Kuma.
Yes.
All right. So the chosen technology is Cilium. Let's see Cilium in action.
Cilium in action. Okay, put my screen on. Okay, let's do it. So I have here wrongly named MTLS, authentication between processes, basically. I'm going to set up a couple of pods just to demonstrate how those things work, so that I have some other things to connect to my application, just running it. This is just for demonstration purposes, additional pods. What does matter is if I do kubectl name production get Cilium, what is endpoints, we should see now that those are the endpoints that are detected by Cilium in this namespace in production, right? My application, those are the first three pods are my application, and those are additional ones that we will use in a second, right? Now, we can extract identity because I installed Spiffy in my cluster because Cilium requires Spiffy for all this magic. And we're going to talk about Spiffy later. What does matter is that if I extract the identities, you can see that the application, the sleep application, got an identity, and this is the identity that was assigned to it by Spiffy or Cilium indirectly, directly Spiffy, and so on and so forth. So every single pod now, at least in that namespace, has identity. And if we want to see more information, we can retrieve the Spiffy Cilium identity, and we can see all the stuff that nobody cares about. Now, what does matter is that communication now between pods in this namespace, they are secure, let's say, right? Now, what happens if I would like to deny some applications to communicate with my with some other applications, right? Right now, if I go to the sleep container, sleep pod, and install CURL, I'm just installing CURL, we can see, I'll get back to that, why I installed, I know why I installed CURL. I installed it so that I can go to that new application, just send a request to the other one to show you how all that works, right? What I will do is create a network policy, Cilium network policy to be more precise, that will say, hey, from the endpoint, actually first, this will apply to all the pods that have the name label set to CNCF demo. So applies to CNCF demo pod, and it says, hey, input to this application is allowed if it comes from another endpoint, and that endpoint has a label up set to sleep, right? So if it comes from sleep in the same namespace, you accept that request. If it comes from somewhere else, don't, right? So I'm going to apply that policy. There we go, applying it. And now, if I send a request to the application from sleep container, from sleep pod, what happened here? Sorry. From the sleep pod to my application CNCF demo in production namespace, it should work, right? Because I allowed that that communication to happen, right? Now, if I apply the same, create the same pods in the default namespace, here we go, default. Now this same pod somewhere else should not be allowed to communicate with CNCF demo because it was namespace policy. So I'm going to install CURL in that other pod as well, and I'm going to send a request. This will probably work, and it shouldn't, but let's see. Yeah, you see, blocked. I mean, nothing means that it's trying, and Cilium is not letting it pass, right? And eventually it will time out, and then you will get an error message, right? Eventually. It will time out sooner or later. Doesn't matter. What does matter is that it's not allowed because it does not match the rules, and the rules are, you can be called sleep, but you need to be in production, not in the default namespace. That's the policy. Excellent. You saw the policy, and you saw MTLS-like feature as well.
So one thing about this particular episode and this particular choice that we created is that you're probably choosing these technologies to do other things besides secure pod-to-pod communication. So while
Yes.
Cilium's the best choice for this, is it the best choice for generally, do you think, between all these technologies?
So Istio and Linkerd are more feature rich, right?
Mm-hmm.
So you can find things that Cilium does not have.
Mm-hmm. With
Now the
like
question is
advanced traffic routing, like that sort of
exactly,
thing?
exactly.
Okay.
Because traffic routing is actually very important. It might not look like, but if you jump into doing something like canary deployments, right? And
Uh-huh.
say, okay, the new release gets 10% of the traffic and the old release continues having 90%. So those are certain networking rules. You can do it actually with all the solutions we mentioned today, but that's an example kind of like, hey, networking sounds boring, but it's actually very important for many, many different tools.
Mm-hmm.
That being said, the question I believe is, did you choose Cilium or something else like Calico for CNI? If you
Mm-hmm.
chose Calico, go for Linkerd or Istio or whatever, right? If you chose Cilium, I would also say go for Linkerd or Istio, but if you see that what you need to do is missing, right? You can always add things.
Ah.
That's not a
Try it,
problem.
try
But
it in Cilium first and
so
then only add.
being less feature rich does not necessarily mean hey, because you're going to use it as CNI. So not having all
Mm-hmm.
the features does not mean that it's bad. It just means that you either need it or you don't. And if you
Mm-hmm.
don't, why install additional stuff on top?
That's great. And it's a good point that you can install additional stuff on top if you need to.
Yes. You cannot
And
easily replace CNI, but you can easily add service mesh on top if you need it.
yes. And even Ingress would do the Canary deployment example. And then
Yes.
when we say Istio has everything, Istio even has an ambient mesh that uses eBPF, I believe. A sidecar-less mesh. Yeah.
So with ambient you lose some features, right? So you're not gonna get all the features. You might use ambient mesh, you might not use ambient mesh, use let's say standard Istio. You might want to combine both.
Would you use Cilium and ambient? I don't know.
Most likely not, because the features, there is more parallels with Cilium features and Istio ambient mesh features, right? Those that are potentially missing are more likely to be missing from standard, let's say, non-ambient, not eBPF Istio.
Got it. Cool. Well, that wraps up pod to pod security, communication, securing those. And so next we're talking about Kubernetes scanning, and we have two tools, Sneak and Kubescape. Tell me about Sneak.
Sneak has been around for a long time, and it has more features and things it does than a magician. It does everything. No, it's a kind of it's a dinosaur, and when I say dinosaur, I don't mean now in terms of being old and bad, not at all, but dinosaur in terms of size, right? Kind of like it's one of those big security solutions companies that cover everything you can ever imagine, right?
Yeah. They describe their product as a platform, which I think happens when it starts to get to be so
Uber
full featured.
platform.
Yeah.
Uber security.
Uber, yes. So let's just come clean right now and say, at this point forward, we started including some projects that are not CNCF projects. So Sneak actually never had a chance of getting chosen because it's not CNCF. But we included it because Kubescape is the only Kubernetes scanning tool in the CNCF, and we wanted there to be some friendly competition. We wanted some context.
Exactly.
Yeah. So let's just talk about Kubescape generally first. What is Kubescape?
Security scanning and a few other things focused exclusively, as far as I know, I might be wrong, focused exclusively on Kubernetes, right? So,
Yep, that's right.
and I think that's usually the differentiator, between big Uber solutions, right? They do everything, and then you can have, what I'm going to say does not always work. Sometimes it fails, sometimes it's bad, no matter what. But you have solutions that are more focused on a certain area, right? And to me, that's you could, in a way, you could compare Snyk with OPA and Kubescape with Kyverno. Not in terms of what they do, right? But kind of
Okay, I see. Yeah.
both are focused almost exclusively on Kubernetes, while both Snyk and OPA are covering much wider range of things or scope, right?
Yeah. That's a great analogy. That's helpful. Thank you. So Kubescape, let's say it says about itself, it's a good starting point for Kubernetes security because you can just enter your cluster, it'll scan your whole cluster, and it's going to look at your configuration. So it's going to look at your like control plane configuration, your workload configuration, your RBAC configuration, and it'll spit out recommendations for that. What you're doing well. Do you have your secrets encrypted at rest? Is your Kube API endpoints on a private network? Like those sorts of things. And then...
not necessarily. So like, for example, whether your secrets are encrypted at rest, that depends on whether you have access to the control plane or no. So if you set up your
whether
own
you
Kubernetes
give it
cluster,
access.
you can say, hey, I have access both to control plane nodes and worker nodes. If you use managed solution like EKS, GKE, Alibaba, what's or not, then you don't have access to everything, right?
Okay. So if you do have access to it, it's something that it can give you. It can tell you that you're doing a good job or you're not. And it's using actually using OPA, Open Policy Agent, under the hood for the configuration scanning part of it. And then it also does vulnerability scanning. So it's going to scan both your container image and running workloads for vulnerabilities. And that's ongoing. The configuration scanning is more or less one and done because it's not unlikely to change. And then it does ongoing vulnerability scanning. And it's going to filter out all the vulnerabilities that are not important. And that's that. And then it also, under the hood, it uses Gripe for that piece of it. And then it also can offer hardening and remediation proposals, which is honestly the fuzziest one to me. But under the hood for that one, it uses Inspector Gadget, which we haven't covered yet. Therefore, I know very little about. What I do know is eBPF-based observability. And that's Kubescape in a nutshell. Is there anything you'd like to add?
No, it's awesome. I mean,
it's awesome.
Both of them, I use both of them, and both of them are great tools.
Cool.
Since we're talking about CNCF, it's the only tool of that kind, and it's good at the same time. Sometimes it's not both of those.
Very good point. Okay, so Kubescape got chosen, and it did legitimately win the vote. But even if it didn't, we were always going to demo it because it is the CNCF choice.
Yeah, so Kubescape...
Victor, why do we do only CNCF tools on this show?
Because we don't want to die trying.
Because we have to scope it somehow.
Yeah, when we won't do all CNCF tools because they're being created and contributed to this foundation faster than we can manage to do them. So we are going crazy with as is. Don't increase the scope, please.
All right, so you scanned the cluster that fast.
Yeah, there we go. She gives me recommendations and stuff like that. I can customize it and say I don't want those, ignore those, and so on and so forth, right? I can, as you can see here, I can say, no, I don't want to scan both MITRE and NSA. I want to scan only NSA.
Okay.
That will give me...
So NSA is National Security Administration or something? Is that what that acronym is?
I don't know. It's not my country, Whitney. It must be your domain. Yeah, exactly. NSA, I think it's National Security Agency or something like that. Anyways, here are the recommendations. This is medium, this is high, fix it, don't fix it, all that stuff, right?
Yeah.
We can scan images. Here we go, right? I can scan my image that is already in the registry. And then it will scan it eventually. Probably.
You're using a CLI, a Kubescape CLI. It's an operator too, yes?
Not sure about that.
I think it is. I think it also has a GitHub action
There
in
is,
operator.
it can run as an operator. You're right, actually. Yes, it can. I find it a bit. I'm not sold on operator for this, to be honest. But yes, it can run as operator.
Cool.
Anyways, my image has 16 high vulnerabilities that I'm never going to fix because this is a demo. But it's a good one because it demonstrates that there are vulnerabilities, right? And I can, no, let's do this. Kubescape scan workload, right? I can scan specific workload instead of the whole. This is probably what you would do in CI/CD pipelines, right? I'm deploying one way or another something, and I want to scan only that something. I don't want 5,000 different pieces of information related to a cluster. I want to see what is happening with my deployment called CNCF demo in the namespace production, right? So I can focus it on certain workload or something like that, and it's scanning what's running over there, and eventually it will tell me that probably I did something terrible, right? There we go, 16. Hi. I bet that most of those are the same vulnerabilities as for the image, right? Not all of those. No, there is more. Anyways, there we go. Scanning.
Cool.
Done.
Awesome. Cool. And then the next episode, we talked about signing artifacts. So we had Notary project, SigStore, and then we had a Misfits, open policy containers. Open policy containers, while scanning is signing an image is part of that. It's not really about signing images. So very quickly, when open policy agents, when you have an open policy agent policy, it is in a bundle, and that bundle is like a values, like a data file and a policy file. I forget what else. But those bundles are just tarballs that can be distributed however you want. And they're not versioned. They're not immutable. There's none. So basically, open policy containers is taking the OPA tarball and it's making it into an OCI artifact so that you can add metadata and you can add versioning and you can distribute them as you would OCI images. So that's out of the way. We're not going to talk about that anymore. Is there anything you want to add on that one?
No, nothing. Nada.
Hindsight being 2020, I would have put that one in the Misfits category and we let them choose where they wanted to go. So we have in our episode, really the crux of it is Notary project and SigStore in terms of container image or just artifact signing, not necessarily container image signing. So what is artifact signing?
It serves probably two primary purposes or functions as far as I'm concerned. One is to validate who or what did something. Who created this thing, right?
Attestation.
Who made this image, right?
Okay.
So that we know whom to fire when things go wrong. The second is also as a way of confirmation that certain processes were executed, right? I can say, hey, I just run tests, and I'm going to sign the image saying tests done. I mean, you're not saying that, but just by signing with a specific as a specific user, a specific key, you can validate. So you can have multiple signatures on there and say, okay, the security department thumbs up, right? Signed it. Testing group signed it. Those signed it. And then when you collect all the signatures, it's like preparing for elections, right? You can move forward.
So that's like a supply chain. Or I've heard you like signing is good, not just for container images, but for SBOMs or other use cases too. Any artifact, not just container image.
I mean, kind of, if you cannot validate that the image is which is supposed to be, or the artifact which is supposed to be, then kind of SBOM is not really that useful anymore because it can change at any time. We can override the image and you think that it contains this and that. I would say that signing is kind of prerequisite for certain things, including
Okay.
doing stuff with SBOMs.
So signing is like, it involves identity. It's like I am authenticated to something through my Gmail or whatever, through my Google identity. And then I say, I made this image, and then I can sign it. And then there's some sort of like digital certificate and proof that someone, at least with access to my identity, said that they did something. But what, like, there's no like verifying what I could say anything. If I'm a liar and like sign it, it doesn't matter.
No, but
So,
you're a liar.
yeah.
You know that it's you who's lying. It's the
Yeah.
same thing as notary, right? A real world notary. I don't know, you're buying a house or something like that.
Right.
It's the notary could be lying, right? But he
Yeah.
put his signature. There is his name. We know who actually validated that purchase
Yeah.
or that sale.
I like, if so a signing verifies that a human or a process with a certain identity says that it did something,
Thumbs
but
up.
it doesn't verify
right.
the truth of that statement. Yeah. So that's I think an important thing to note about signing. It's safer, but it's not perfect.
You know, depends. You know, kind of most signings are. I hope that there aren't many people who are signing it manually, like what I'm about to do soon, right? Signing
Yeah.
is happening as part of the processes. Okay, there is a pipeline that runs tests and signs at the end of the process, right? And we know which pipeline was executed. We have logs. It's stored in Git and so on and so forth, right? So it's if we can validate all those things. We can actually check whether really what's behind that signature is what is supposed to be.
Yeah. So then signature validation is important too, how that's happening. And it's like when you're using a third party tool, bringing that into your cluster, like I can verify the Ubuntu signed that it made the Ubuntu image that I'm about to use as the basis of my container. So it's a good way to verify it. Yeah.
Good example of the doubt you were having is very often when you use third party images, let's say from some company, right, that is giving you certain service, they would give you a signature and you can validate whether that signature in that image matches the signature that they gave you, right? Now you don't know what they did, but you know that it's image created by them, right? And not the image that was injected somehow and you're using something false, right? I mean, it could be wrong still, but you know, okay, so this comes from that company.
Yep,
right?
it wasn't modified in transit. Yeah.
Exactly.
And I feel like I had something else to say about it all, but I think it's gone now. That's okay. Yeah, I don't know. So that's signing, and we have Sigstore and Notary that both do signing, but they do it differently. Do you want to speak to that, or shall I?
I think that the only difference that I'm aware of is the way how they use the keys for signing. So, but you probably know more.
Yes. So Sigstore. Oh, I was going to say the attestation. The signature is part of, I believe, the metadata of the OCI object. So it travels with the OCI object, and you can choose to verify it, or you could choose to run it without verifying it. So just because it's there doesn't mean it's going to stop you from using it if it doesn't match, if you choose to use it. Anyway, so Sigstore signs images, or the signature is done with a short-lived X509 certificate. And so it's done, the signature happens, the X509 certificate, the private key only lasts for 10 minutes and it's discarded. So you have the liberty of not having to manage secrets or manage certificates as part of using Sigstore. Now the compromise you're making, so when an image is verified, a Sigstore image is verified, that signing event, when the signature is created, that signing event is persisted in a public log. So it's Recor is the subproject that does that. And so that signing event is public, and part of the verification process is checking that the date and time on the signing event matches the 10-minute window of the X509 certificate. And that is awesome if what you're signing is something that's public anyway. But for a highly regulated industry, maybe you don't want anything that you're doing being persisted to a public place. And that's when the Notary project is better. So Notary used to be a legacy client server that did signatures way back in the day, but now they have the Notary project, which is a specification for how to sign images. And then they have notation, which is the implementation of their specification. And notation is going to use, like, you probably, if you're a big corporation or a big enterprise, you probably have a CA in place that you already trust and you want to use your own CA. And with Notary projects, you can do that. You can use the PKI infrastructure that you've already been using forever as part of signing and verifying images. Yeah.
I agree.
You look so bored. So this was another one that was a kind of a false choice because Sigstore is not a CNCF project. So Notary project is the one. It also won the votes, but even if it didn't,
Yes.
it was always going to be the one we implemented.
Okay. I see you put the screen. That means it's my turn, huh? Okay,
Yeah.
I'm going to build a new image just to show everything from the start. I'm actually using TTL, which is a public service that is awesome because I think that it deletes images after an hour. You're not going to use it for production, but
What
for
is?
demos and stuff.
I think of Time to Live as TTL. What is
It is.
that? Okay.
I mean, that's where
What
the
is
name
it doing?
comes.
Uh-huh.
Basically, it automatically deletes your image, I think, a day later, and you can specify also that it lives shorter. So it's temporary registry, right? It has no real usage in the real world, but very useful for what I'm going to do, right? So I built it as build the image, and I'm going to push it now to TTL. There we go.
Did he freeze,
What
Victor?
happened there? There we go.
Oh,
We're back now. I'm going to, when it's pushed, sooner or later, I'm going to get image digest, which is the long digest SHA of the image. This one, right? I just have a command here that will actually extract it. There we go. And the reason why I'm doing that is that now I can use notation and say notation ls that image digest. And it will say has no associated signature, right? This image that I just pushed was not signed. Now what I can do is repeat the same command, but instead of ls sign. Now, by the way, when I sign it, it will push it to the same registry of the image itself, right? So it's signing it and pushing it to the registry. And now if I do verify, we can see that it should, there we go. Successfully verified signature for TTL, blah, 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 right? Now that it's signed, I can verify and confirm. Same thing if I do ls over there. You see before it said no associated signature. Now you can see that that image is signed, in this case by me, with my keys, right? And that's all there is to it, right? Sign it, validate that it's signed by whomever claims to sign it, and that's it.
That's it.
Not
And
much
then
more to it.
Yeah, with Notary project, it has you can do revocation strategies. So you can revocate if you could say this one signature of Victor's, it's no longer valid.
He's a crook.
And don't trust it. Or you could say everything Victor ever did. That's not valid. No longer trust that. Yeah.
Yeah, I mean, I'm not sure about the use case for that. I understand the use case. I'm not sure because it's still, this image was still signed by me. Now, whether you stop trusting me, that's a different. I would rather have a mechanism to say, no, this person or this process shouldn't be trusted, rather than not signed by him anymore, or it. But
and I'm revoking an identity. You can do that. You can revoke a signature, or you can revoke an identity.
That's the thing.
You can do it either way.
Yes.
Yeah.
Yes.
Okay, the next one is generating workload identity. So that one we talked about Spiffy and Spire in Athens. So Spiffy is a specification, and Spire is the reference implementation, and Athens is another implementation of Spiffy.
I thought it's the other way around. Is it Spiffy?
Oh, Spiffy. Did I say the wrong thing? Spiffy is definitely Spire's the implementation. Spiffy is the specification. Yeah. And so Spiffy is a more secure way to secure identity, I guess, between workloads, but I suppose it could work with people too. So we had MTLS, and it does work for her both, actually.
Secure my phone or what?
So
people.
we have already MTLS, we have like certificates, and we have tokens as a way to do this type of security. But now we have Spiffies coming onto the scene and hoping to replace those things. So besides not needing to manage that stuff anymore when you have Spiffy, it also, similar to when we talked about network service mesh, like right now we have a trusted network and then two workloads can talk if the two networks trust each other. With Spiffy and Spire, and you can have untrusted network, but two workloads can trust each other within, even though the whole networks don't. But the way it works, so the way we talked about attestations, and we can't actually verify that what the workload is attesting is true. So basically, Spiffy's come up with a way to verify that what the workload is attesting is true. Are you with me, Victor?
Oh, I'm comfortable.
I hear that you didn't how you answered / did not answer my question. Okay. So basically there's Spiffy agent and Spiffy server. So Spiffy server is like the CA for the Spiffy. It's the trust domain, and the Spiffy agent, there's one per node. And the Spiffy agent, the workload can attest itself and say, hey, I'm this workload. I'm running on this node. I'm using this base image. Whatever you want it to say, that part's configurable. And then instead of it, in the image signing version, we're like, okay, we'll put your identity. We'll trust you, whatever. But now with Spiffy's going to actually verify. It's going to search around your environment and actually verify, oh, you really are running on the node you say you are. You really are running the OS you say you are. You really are doing the things you say you are. So then when it issues its identity, that has actually been verified. And when you implement Spiffy and Spire, you customize what you want, like you use plugins to customize what you want a verification to look like what things you want to look for before you verify it. But then once you get your Spiffy ID it looks like a URL, and it's cryptographically verifiable. And the Spiffy ID is wrapped in an SVID, which is a Spiffy ID verification document, whatever. But people can kind of say SVIDs or Spiffy IDs interchangeably. They're technically two different things, but they're the SVID contains the Spiffy ID, and it's wrapped up in a bundle of PKI certificates. But anyway, once the two workloads each have an SVID and they're connected to each other, they can totally, completely trust each other because they've been verified. And the whole thing's automated, and everything, there's short-lived certificates also that automatically gets refreshed, but you don't have to do anything. Like the Spiffy system is taking care of it all for you. Yeah. So Spiffy is a pain. It seems very complex to implement, and it happens like at a organizational level. Like as someone who's worried about one small piece of the system, you would never use it. But I think it's cool, and I'm excited about it.
It is, but there are very few organizations that will be using Spiffy directly, right? Kind of that's reserved usually for organizations that want something very, very specific. You are more likely going to use Spiffy Spire without knowing. It's going to be part of something. And that something could be
Cilium.
Cilium?
Yeah. But so Spire is the reference implementation of Spiffy. And so it's everything. And then Athens is its own thing. And Athens, so Spire has one agent per node, like per machine. And with Athens, the way it does the same thing where it generates an identity and it has an agent that can collect information and can verify that the identity is true. Like it's reading stuff from the environment to verify it's true. But with Athens, that's happening at a sidecar level. They have an Athens agent coming up with every single workload container. That it's in their roadmap to factor it out, so it's a node level thing. But it does support Spiffy's SVIDs. And then Athens also has the added benefit of supplying roles, so you can do some authorization. It does some access control element part to it too. There it is. And the people chose Spire. So Spiffy wasn't a choice. Yeah.
There is nothing we should do.
Because we already
showed you Spire.
Because we already did it as part of Cilium.
When we saw Cilium, exactly. It's already part of it. And thank you all for choosing Cilium. Because if you chose something else that doesn't use Spire, then I would have to implement it. Now I don't.
And now I don't have to figure out how to set it up.
And I can continue being reclined with my legs up and saying, continue, Whitney.
So that's generating workload identity. Is there anything you'd like to add before we move on to the next one?
No, nothing to add.
The next system design choice is authenticating users. So this is like human users who need to get access to the system. And for this, we talked about OIDC and OAuth 2, which are specifications. OAuth 2 is a specification for how to get an identity token and like refresh token. And not an access token, excuse me, and a refresh token. And then OIDC is how to get an identity token. I see you pulling up the next demo behind the scenes. So OIDC
being hands off
is a specification for how you get permission from OAuth 2. Yes. And then it standardizes how that information has to look. When I think of OIDC, it's a little fuzzy to me, obviously. But when I think of OIDC, I think of like the world now that like back in the day, early internet, I had to have a different username and password for every website I went to. And it was confusing to keep track of. And now those are being reused. Like it's going to be, I'll be like, do you want to log in with your Google or with your GitHub or with, like, it gives me choices for identity providers I already know and I'm used to. You switched our sides.
I'm all into pleasing people.
Oh, so Victor and Whitney need to switch sides of the screen. This is all wrong. So OIDC, OAuth 2, OIDC, we're talking about tokens now. OIDC gives an identity token. OAuth 2 is access tokens and refresh. Yeah. And that's the context you need to talk about DEX and Keycloak. What do you have to say about DEX?
Nothing. I haven't used it, so I know I know only what people told me, and that's probably a lot if I paid attention.
Keycloak, similar to Istio, is one of those technologies that does absolutely everything in the space, everything. And so as a new person learning, it's a little overwhelming and hard for me to understand, to pick apart like what it really is. But you look like you want to say something.
Yes. If you're going to jump into Keycloak, I suggest not having any deadline, not having any other project that you're working on, not having anything. You can dedicate at least a month just to understand what's going on.
Yeah, that's what.
And then some more time to add it to your applications.
Yeah. And that's how some of these bigger projects get. Yeah. So you can define a whole login flow and what you want it to look like. And there are lots of infinite ways to customize that. And then Dex does one little teeny piece of that and does it in a Kubernetes specific way, which is it makes it through. Right now in Kubernetes, you can only use one identity provider to authenticate to Kubernetes. So basically, it makes it so you can use a lot of different identity providers. You could use SAML and LDAP and Auth2 and all the things, and OIDC itself. But it makes all those talk to one another in OAuth2, and it makes it so you can use lots of different identity providers with one single Kubernetes cluster, which you couldn't do before, which Keycloak can also do, but Keycloak is overkill if that's all you need.
Yeah, if you're not planning to spend months, Dex does not give you everything that Keycloak does, but
no,
you will not get this color in your hair that fast.
Dex doesn't even do, I think, a small fraction of what Keycloak does, but yeah, it's simple, it's lightweight, and it's great for this one use case.
I might be wrong, but I think that Dex is, as an example, I think it's part of Argo CD, for example.
Yeah, it is. Sigstore uses it too. Mm-hmm. Yep. All right. Are you ready to? Keycloak is the one that got chosen.
Okay, there we go. Keycloak installed. You can manage it. You can manage stuff. You can create clients. You can create client scopes. You can do a bunch of stuff, which I'm not going to do because we are already 2 hours in this.
Yeah. Yep.
That's a go.
Users, groups, sessions, events.
You can do everything over there. It's all clickety click. You have API that is very, very hard to master. And you will, but once you set it up, then you need to modify your applications. Your applications are just going to communicate with Keycloak as if it's any other OIDC provider. Keycloak is going to say yes or no, kind of like this user exists, this user doesn't exist. And that's the gist of it.
That's the gist. Cool. So then we come to episode 9, which is authorizing access. So then, like, our users has an identity, and now what can they do now that they're in there? And so they're different. We talked about 3 different technologies for this, and they're all very different from one another. They're like oranges, not apples to apples, but oranges to semi-trucks. Yeah. And so the 3 we have is Hexa. And Hexa is about, it has a language called Identity Query Language, IDQL. So it's creating a standardization for how to write access control policy. And then it's creating Hexa integration code to, so that you can write your access policy in one language, and then that will get translated to all the different places in your enterprise, in your system that need to use that. So like right now, as it stands, all your different major cloud providers, for example, have different ways that you would write access policy. So Hexa's goal is to write access policy in one place with IDQL and then be able to use it anywhere.
Yeah, that's the advantage, right? Probably Hexa would be the overkill by itself. But if you have multiple ways to manage permissions, then you can use Hexa to wrap it all together, right? And provide a single interface through many, many different access providers, right?
Yep. So that's Hexa. The other one is Perilous. Perilous is all about making it easier to deal with RBAC, or role-based access control.
Yeah. So what is special about Parallels? I mean, special, different, right? At least, especially compared to the one coming after, is that it is mostly for human access, right? Kind of, you human Joe needs to access this Kubernetes cluster, and and Joe can go to Parallels, download kubeconfig, and that kubeconfig already has everything set so that when he accesses, or she, Joanna accesses the cluster, that access is limited to whatever we want to limit it, right? Okay, specific namespaces, specific resources, read, write, stuff like that.
And so it's especially beneficial. You can manage access to lots of different clusters in just one place. And then it also, you can do audits, like it gives you visibility into what's happening. So it's a lot easier to have observability and also to troubleshoot or to revoke someone's access.
Actually, what I said before, that when you download kubeconfig, you're not actually getting access to any cluster. You're getting access to Parallels, which tunnels the access to a cluster, right? So you're using intermediary that will forward that connection to wherever it should go, right?
Exactly. Parallels sits between the human user and one or many Kubernetes clusters.
Yes.
Yeah.
It's like your mother when you bring a boyfriend.
Yeah. It's on the couch in between the two of you.
Or father.
When you're trying to watch a movie.
Yeah.
So then the third one, I'm laughing, is, never mind. I'm laughing. The third one is OpenFGA. And FGA stands for Fine-Grained Authorization. What is OpenFGA?
So it's similar to Parallels, except that Parallels is for Kubernetes cluster, and for humans, OpenFGA is a way how your applications can validate whether, let's say, a user of that application should have access to something, right? Kind of more often than not within that application. So, typically when you go and log into some application, can you do this or can you do that, right?
So it's like, I think of like Google Docs, the way you could share a Google Doc with someone, like OpenFGA might be good for that use case. Or maybe a support technician should only be able to access resources available, like connected to their open tickets.
I might be wrong, but it's more within an application, right? You're writing your own application and you have users of that application. And, can this user do this, which will result behind the scenes in me posting, storing something in a database, right?
I honestly think it's both.
Yeah, I mean, it could be both, of course.
Yeah, I'm quite sure that my part is right, but your part seems right too. And like
consensus. This is good. You're right. No, you're right. She's like Oprah. You get this, and you get the present, and you get the present. Everybody gets a present. Excellent.
Yeah, that's a dream. So RBAC is much coarse-grained compared to OpenFGA. And then there's also like attribute-based access control, which is comparable, but that's different because at the moment of access with attribute-based access control, at that moment you need access. It needs to do, it needs to fetch and like see who you are. And it needs to do computation about whether you're allowed to have access. It's checking your relationships and it's checking, I forget the second thing, data. But it has to do a lot at that moment. And so with OpenFGA, there's a whole OpenFGA relational model that's stored. So when at the moment that someone needs access to something, they need to consult the model to see if you have permission. And it's a quick yes or no. The computation's already been done. And so it stores relationships. Yeah, I lost you again.
I agree.
But
I'm not following, but I agree.
I lost you again. I agree. So it stores relationships, basically. So are you ready to demo? So OpenFGA is what got chosen. It's super cool. Are you ready to demo it?
I'm not ready to demo. I just realized while we were talking that I made a mistake by installing OpenFGA server in a way that I cannot access it anymore. I'm locked out of
Oh,
it.
no.
Yeah. So I'm getting forbidden by administrative rules, and I have no idea why that is happening. And you will not see the demo.
Oh, yeah? There's no
I mean, there
attempt
is,
at
I can
troubleshooting?
disconnect while we speak and then try to figure it out. But yes, yeah.
So,
Actually, yeah, I can try to figure out while we speak. Why am I locked out? This is the worst thing about any type of authentication system, that when you get locked out of your own system, it's bad. Like really bad.
yeah. So that brings up the point, though. The actual the authentication step is outsourced. OpenFGA is not concerned with how you get your identity and present it. It's not concerned with that. But what it is, when I say it stores relationships, what it stores is it knows the user, it knows your identity as a user, and then it knows relationships, and then it knows the objects is the subject. Or I'm thinking of grammar now, like grammar sentences, the predicate. Never mind. But it stores a relationship model. And at the moment, the relationship, it's called an authorization model, is like organization wide, which seems pretty huge. Like I know it's on their roadmap to break that authorization model down into smaller pieces that can be managed independently. What are you doing to troubleshoot right now?
No, I'm just trying to figure out what I did wrong, but most likely, no, I don't know how to fix it, at least not fast. So we will not see OpenFGA. No. And that also means that this is almost the end of the story.
Spoiler alert, we have one.
Next soon.
So, cool.
All I will say for now is that this is the last demo you will see. This is the last time you will see my screen today.
Okay. So the final episode is what we started calling the Misfits. The title of the episode is the Misfits, but we've come to lovingly refer to as the Weirdos. So these are projects that didn't fit into any particular system design choice bucket. And it is containers SSH, plural, right? Container SSH, singular. And then it is confidential containers, plural, which that project calls itself Coco, which I think is adorable.
I love the name. Name is cool.
So let's talk about confidential containers first. What's that about?
Making containers be infinitely more secure than they normally are, which requires one of the two things. There are three options. First, you have dedicated hardware for that. Not many do. You can, your cloud provider, hyperscaler, might support it, which they don't.
In which case, they have the dedicated hardware. Yeah.
Exactly. But they might in the future. Or you're ready for pain.
I think you need hardware.
It can be set up without dedicated hardware, but it's far from trivial.
Yeah. Oh, I didn't know that it even could be set up without dedicated hardware. So the idea is...
I'm just enthusiastic. It can be done.
The idea is whoever owns the machine that you're running Kubernetes on or anything on has access to that whole machine. So you can't trust it. They want to come up with a way to do computing and where the owner of the machine can't possibly see what you're up to on that node. And so they'll say like data's encrypted when it's in rest, it's encrypted when it's in motion, and it needs to also be encrypted while it's in use. So yeah, it's an extra level of security that I feel like the only way anyone would be motivated to implement it is if the government or some regulation makes them.
Likely, yes. So it really, what is really required, I mean, it's not necessarily a bad idea. I think it's a good idea, but it requires much wider adoption, right? And less friction.
So confidential computing is does this at a large scale, and confidential containers is about doing this within Kubernetes, bringing confidential computing into containers running in Kubernetes. And I think that's all we're going to say about that. Does that feel like
that's all there
enough
is to know about it? Yes.
Okay.
That's enough.
And then we have container SSH, which is the one that you're going to do a demo about here in a minute.
I will not. I will not.
Tell us everything.
So the first thing is that I did go through the docs a couple of times, and instructions simply do not work. I tried kind, it didn't work. I tried tricky, I believe, it didn't work.
The abstractions don't work?
The instructions don't work exactly.
Instructions, got it. Okay.
Yes.
And, well, first of all, what even is it?
So I had very different image of it than I have now after we did the session. I thought it's about having SSH server, which does not seem to be the case, to my understanding, which might be wrong. But it's more like a ephemeral container that you can go there and you can SSH into it, great. But from that container, you can do additional things like maybe spin up some other containers, maybe create some development environment, things like that. So I'm not even sure that we rightfully put it in security, and I feel that it would be a better fit into the first chapter, which was development, together with, I don't remember what we had over there anymore.
Dev space, dev file, telepresence, localhost.
Exactly.
Yeah.
Okay, together with those, exactly.
Yeah. So yeah, that's what
I quit to. So I will be honest, kind of like I did not spend more than an hour with the docs. I could probably figure it out, but I wasn't. I gave up.
We gave up. So Rashid said it's good for like a lab environment, or a good for to be able to hop in and do some tests or something. But so those are the weirdos, and neither one's getting implemented right now. Because that's the note we're going to go out on. What else? That's it. We did it. We covered every single security project that we know about. Right.
It didn't work at the beginning. We figured it out. It failed at the very end. Almost. Yeah. We almost did it. It almost happened.
It's been a roller coaster.
So sad. Two failed, 8 successful, give or take. Bad, actually.
Yeah. It's a passing grade. We graduated and now we get to move on to observability. So now we'll take a break for several weeks / months, but we'll be back to do observability with y'all and start talking about every single observability project in the entire CNCF. So I can't wait.
That's why you saw Kubernetes dashboard in the demo today. Mistakenly.
Excellent. We did it. High five. Thank you, everyone, for being with us. Thanks, Victor. Bye.
Cheers, everyone.